Scott McAllister joining us. I'm super excited also to have Scott on board tonight. Scott was one of the first speakers that we had on our JAMStack Seattle meetup back in the pre-pandemic times. So we actually got to meet each other in person. How crazy does that sound, right?
It didn't seem crazy at the time, but wow, that was such a long time ago in terms of, you know, how things are today.
Everything. Yeah. So I think that you can say that you with today you can graduate from being a speaker at JAMStack Seattle because you've been on all of the modes, like in person, virtual, right?
Right.
Yes. So a little bit about Scott. He's a developer advocate at PagerDuty. He's been building web applications for several industries for so long, over a decade. Sounds like so long. It's like a different internet and everything technologies back then. So I can only imagine. And now he's helping others learn about the wide range of web technologies and incident management principles, which is super exciting. And when he's not coding, writing or speaking, he enjoys long walks with his wife, skipping rocks with his kids. I can't speak today. And he's happy whenever one of all those
there you go. Yeah, I was gonna say, just say all my sports teams.
all of any of those, yeah, can manage super big on that. So we're super happy to have you tonight talking about client-side OAuth with, how do you even pronounce that?
It's PKCE, actually.
Okay, PKCE. Yeah. Okay, there you go.
Yeah.
Fantastic.
That's what helps me remember how the acronym goes. So I think of PKCE. So yeah.
Sounds great also. Cool. Take it away. Welcome, Scott.
All right, awesome. Thank you so much again for having me here. I'm excited to talk to you all a little bit about something that I've discovered recently as an engineer, and it's something that we at PagerDuty, where I work, we support. Oh, and I hit the wrong button. Yep, I've zoomed before, I promise. There we go. And we'll do that, and then that will be a lot nicer there. And you can see my slides, yeah? Awesome. Okay. So essentially, what I'm going to do is we're going to talk a little bit about something called OAuth, which as web engineers and web developers, you've probably seen maybe a little bit, but I want to talk about the history of it and then talk about a kind of a new standard of OAuth that is super beneficial to those of us who are building client-side applications and especially JAMStack applications. And so the principles I'm going to be talking about today can easily be used inside of a JAMStack app. My demo, I'll give away the ending a little bit. My demo does not use a JAMStack platform. However, you can see the principles that we use today and you can easily implement them inside of your client-side JavaScript code. So think back. As was mentioned, I've kind of been in the industry a while, and long time ago, web applications started coming around, and they were super useful. We had applications that did our calendaring or email. We did email inside of our inside of the web browser. But the problem is those web applications were very independent. They didn't exactly talk to one another. And so it was great to go maybe do one thing on this web application and do something else on this other application, but we had no way to really connect them. So at first, we started getting some ideas as developers, and we started thinking, all right, let's see if we can just get some data from, say, like, and this is totally theoretical, but like Google Calendar. And so let's think about this for a second. We have a client application, or you have an application, and you want to get information from Google Calendar. And so the way you would do it is you would actually put a login form on your page, like in your app, and then you take that username and password, and you would expect your users to put your Google Calendar username and password into your web application. And then your code was supposed to send a request to Google Calendar, and Google Calendar said, yep, this is the person who says they are, because that's their username, that's their password. I'll send you that data. Think about that for a second. As a user, you're putting your username and password into code that is sitting on somebody's box, but you're putting your username and password to get into your Google Calendar and your Google accounts. This is something known as the password anti-pattern, and it causes a few problems. For starters, there's no real easy way to revoke access from the client application. So think about this for a second. Google Calendar would have no idea where that username and password was coming from. It just sees a request coming in with a username and a password. It doesn't know which application, it doesn't know what kind of access to give. So it's just going to say, yep, I see this username and password, and I'm going to allow you to have access to this person's data. Whether I know that you really are that person or really are an application doing nice things, I'm still going to give you access to this data. And so if you can imagine, once you allow that sort of access, once you start allow people coming in, it's really hard to stop them. It's really hard to stop people from accessing that data, because it's like the crowds in a big subway station. Once you start letting a few people through, everyone's just going to start pressing on through and coming in. Also, because the application, and again, I'm going to keep talking about Google Calendar as like our example, because Google Calendar doesn't know where that username and password are coming from, it basically gives all the access. It's as if you logged in to that application, and so it says, okay, I'm going to open up all the doors, and you have everything. You can access everything inside of this person's data, and then your application could go in and grab whatever it needed to grab, but it also could grab everything, which means it could grab things it didn't need to grab. And as a user, it could be getting into things that maybe I didn't want you to be getting into as an application. And then finally, if you think about putting a username and password, if it's sitting in your code, like in your application's code, or this application that you're using that's logging into this other service, logging into Google Calendar, you have no idea what that application is doing with your credentials. So you have your username and password, and you put it into this site, and let's say, for efficiency purposes, they're going to save it in their database too. So your username and password to Google Calendar is now saved in this other application. And oh wait, there's this other application over here that you put it in, and this other application you put it in, and suddenly you have basically put your keys or your username and password in a bunch of applications, and you're not really sure who has what and who saved what, and how you're going to be revoking that kind of access, removing your credentials from those applications. And you don't know if they're going to even let you remove them or things like that. So there's a few limitations that you have as a third-party web app who's using this. It's something called simple authentication, where you're just passing the username and password from your application straight at the other application. I've actually seen this in practice. The company shall remain nameless because they are quite big and quite around still. But when I saw it, I was horrified even at the time. So yeah, simple auth is, kind of scary. So the folks who came before us decided this was kind of a scary practice. So let's think of some other standard that could allow a better interchange between our web applications, because we see the power of having this application talk to another application, or maybe getting lots of different information from lots of different other applications. And so they came about with something called OAuth. And OAuth is a standard that allows or that authenticates users and authorizes their access to information. And it's a standard, it's not a product. It's not something, even though there are companies that have names that are quite similar to OAuth, they provide the service of authenticating with systems. OAuth itself is a standard. And it's a standard for authorizing access to, or secured access to, an HTTP service or just another application that we have that we can contact over the network. And it uses tokens rather than passwords. It uses a token that can be created, destroyed, and also it is separate. It's decoupling itself from the fact that it's not just your username and password. I can have a token for accessing my Google Calendar or my Google anything. But if I want to maybe revoke that token to a certain site, I don't have to go in and change my username and password with Google. I just revoke the token, or I just cancel that token, or they revoke my token, or Google revokes my token. But anyway, that way I, as a user, don't have to change my username and password. And so going through OAuth, it provides what's called a secure delegated access to client applications. So these applications can talk to a service. They can talk to, and I'll just keep using Google Calendar for now. It can talk to Google Calendar, and we can say, Google Calendar can say, okay, you're a client, you're this application, I know who you are, and I know that you only have access to read this person's data and to update it, but you can't create anything and you can't destroy anything. And so now you have very specific limitations, very specific scope. You can limit a user's scope so that you can say, okay, I just want to give them access to do this one small thing. That way I'm not giving them access to do all things because I don't need to do all those things. I just need to do these few things to get my application to work with the service application or to work with Google Calendar. So the most common, at least from my experience in the applications I've built, is OAuth using something called a client secret. And this is, I should point out, this is OAuth 2.0. I don't feel like it is something that needs to be talked about a lot, although there are some services that still use OAuth 1. The one that I ran into, honestly, even this year, there was an API used by a service called Discogs because I love vinyl, and I figured, oh, okay, I'm gonna build an app and like do something with my vinyl records, right? They use OAuth 1. OAuth 1, we're not even gonna talk about here because don't use it, please. It's not super secure. It's not super easy to use. OAuth 2 is what we're gonna be talking about today. So that is what the standard we'll be talking about. So OAuth with client secret. Now, for my explanations, I'm gonna be using my employer because, they pay the bills and it's good to talk about the folks that pay your bills. And so PagerDuty is where I work. And they're going to be the authority system or the authority application that we're going to be trying to connect to throughout the rest of the concepts I'm going to be talking about today. And so with PagerDuty, what we're going to do is I'm going to step through a diagram as I talk about things in human terms. But first, when you have an OAuth application or an OAuth connection with a service, you're going to actually create you're going to register an application. You're going to register with that authority service. So in the case of PagerDuty, you would go in and you say, I want to build an application. I want lots of people to use this application, but I want it to be able to connect. I want people to be able to connect to their own data. So I don't have to create a token, or they don't have to create a token on their own. I'm actually going to create a token for them using this OAuth flow. And so by creating this or registering this application by you as a client app developer, as you create an application, you're going to say, I want to build this application. I want to have this access to the PagerDuty data. And then PagerDuty says, great, that's nice. Here's your client ID. This is going to tell me every time that there's a request for OAuth, I have a client ID that's going to be sent to let us know who's making this request, through what application is making this request. So that client ID is going to happen. I'm also going to give you this client secret. This client secret is something that you should not be public, right? Client ID, you're going to see it in a URL. People are going to know what it is. It's a relatively public thing. The client secret, in the words of Gandalf the Grey, is something you should definitely keep secret and keep safe. So in most cases, using a client secret, you would need some sort of server side processing so that you can hold that client secret in a place that people can't find, so that folks can't spoof requests coming from your application from somewhere else. So a client secret, you'll need to keep in something like Node or Python or Java. And so that way you can keep it on the server and keep it safe and away from folks, from prying eyes who would want to do bad things with the identity of your client application. To talk about the concept of how OAuth works, I want to use a diagram that we used a little bit before. And with this, what we're going to do is so on the left is your client application, and then on the right is your authority system. Authority system, again, is going to be PagerDuty because that's what we're going to talk about today and what our demo is going to be talking about today. So the client essentially knocks on the door at PagerDuty and says, all right, I would like to get access to this person's information inside of PagerDuty. Here's my client ID. This is the one that you gave me when I registered. And then also, here's the redirect URL, or here's the address of where to send back the token that I'm requesting or any other messages you want to send me. And PagerDuty says, all right, I see your client ID and I see your redirect URL. I want to make sure the user actually has access, to this application or to this data. And so when the user is going through this flow, they're actually going to see some sort of form that says, if they're not logged in already in that browser, they don't have a session already running, they're going to be asked to log in, but it's going to be on PagerDuty's site. It's not that login process is not going to be on your client application. They'll look at the URL and see, oh, pagerduty.com, log in with my username and password. Then I'm going to be asked, do I allow or deny this client application from accessing my PagerDuty data or accessing my stuff? And that user has to say, I allow this client application to get my PagerDuty information and to do whatever access is listed there on the window there. So PagerDuty says, okay, if they allow, that's fine. I'm not going to send you the token just yet. I want to really, really, really make sure that this is the person that is trying to get this information and that they are absolutely authenticated and authorized to get what they need. So what I'm going to do is I'm actually going to send you an authorization code, and I need you to send that back to me because I want to see if you really are who you say you are, plus if there's no, application in the middle between the two of us trying to intercept data. So your client application will say, that's fine. Here's that application code. I'll send that back to you because I'll show you that it hasn't changed. I've gotten information, this fresh new information on this auth code. I'm going to send you the client ID again because that's going to be on every request I make with you, every message I send to you. And then also I'm going to send you a client secret. This is that secret piece of information that you gave me during registration that I'm holding secret on my server. I'm going to send all three of those things to prove that I am the application you think that I am. At that point, the authority system says, yep, that looks right. You've checked out twice. You've requested once with your client ID and your redirect URL, both things I already knew, but they both match to the records that I have. I sent you a code. You sent it back to me again with the same client ID and then also with that secret information that I gave you. And then fine, that works out well. Here is your access token. And now with that access token, your client application can access the data that is inside of PagerDuty. So this is an OAuth flow that you may have gone through before. You maybe have even built in your applications. But again, it requires some sort of server-side element to be able to do that because you have to keep that client secret in a safe place, in a place that can't be seen or accessed like through the browser or looking, through an inspector, things like that. So this worked out really well for a long time. And by long time in web development terms, it's like, at least 2 years. And so by doing that, we were able to build great applications that have great OAuth. And to be honest, it works in most situations. But now, as the client or as our browser side or client side applications are getting more and more complex, all of us here do tons of JavaScript, right? We know that JavaScript is super, super, super powerful in the browser today. And it allows us to build super functional, super powerful, said that word a lot, I should probably find another word, but our applications inside the browser are a lot more complex than they used to be. And it's making our dependence on a server less and less and less. You look at JAMStack applications, we have JavaScript, we use APIs to talk to other services, and then we have markup and that's it, or markdown, excuse me. And so, but it's all running client side. And so now we have these needs of saying, okay, I have all these apps that run on the client side. How about I do this same process? Can I have this same kind of authentication with these applications? And then also another place you would be doing that or thinking about needing authentication like that is with mobile apps. We're not going to get into mobile apps today, but think about how with a mobile app, if I could do all my authentication without having to hit back to a server, and then I could just do it all straight from that device, that's a lot more powerful, a lot quicker in our performance. So PKCE works really well also with web mobile apps. Maybe also with native mobile apps. I haven't tried. So with OAuth, because of that need to get a little more client side, to get a little more focused on how to not rely so much on the server, there technically is a standard known as implicit OAuth. And implicit OAuth it's okay. It's a little scary, but we'll talk about it here just to kind of talk about the progression of OAuth. And so with implicit OAuth, it basically says, pass me the client ID, pass me the redirect, and here. PagerDuty would say something to the effect of, all right, client ID checks out, redirect URL checks out. Here's your token. I'm not even going to send you through that second step. Yeah. I mean, if you're living dangerously, great, go for it. Or if your data is if it's really not that important that folks are getting, your data is like, yeah, it's important that it's behind a, some sort of authentication wall, sure, but it's like not super vital. To be honest, I don't know how to justify implicit. I probably wouldn't use that either. So, so implicit is one that, again, it has its purpose. I haven't figured out what the good reasons are for it. If anyone knows, drop in the chat or let us know on Slack. That would be great. I could use that information, but it'd help us all learn a little bit more. So, but what implicit did do is it realized that because we needed to get more and more client side or more browser focused, more client focused, OAuth needed to evolve just a little bit. And so implicit came along, didn't quite work with how we needed it to work. And then came along an idea called OAuth, now wait for it, long mouthful, with proof key for code exchange. Hence why we call it PKCE, because if we tried to say proof key with code exchange every time, or even like 3 times in the same conversation, you wouldn't even be able to say anything. So PKCE, just remember PKCE. And then with PKCE, rather than like the flying little fairy dust thing with the X in it, it's PKCE. And the PK, you can remember, oh, right, proof key. That's how I remember the name of it. So with PKCE or proof key for code exchange, it requires a couple more steps in your application's authentication process, but it's super interesting, and I want to talk about it a little bit. So for starters, the client is now responsible for creating its own dynamic secret. Rather than a secret that our authority application says, here's your client secret, save that on a server, and then send it to me, like show me this secret, the secret sign type thing when you're making a request. There's actually going to be a dynamic secret that's going to be generated in your JavaScript. And with that dynamic secret, it's something called a code verifier. The client will also need to hash that value to create something called a code challenge. I'll talk about the terms here in a second, because there are a lot more terms that we talk about when we're talking about PKCE. So for this particular one, the first one, the code verifier, as I mentioned, is that value that we get that's a randomly generated 128 byte base 64 URL encoded value. Luckily for us today, the code that I'll be talking about is a sample application that I have out on GitHub that has this code already there for you. It has this algorithm that just generates this random code for you. You literally can copy and paste it into what you're trying to do. And so if you're using, and the key there with that one as well is if you are interfacing with an API that provides PKCE OAuth. So you have to make sure that the folks that you're trying to authenticate with provide that in their API offering. And so a place like PagerDuty does do that. So anyway, code verifier, random 128 byte, base 64 URL encoded value. Then we have the code challenge, which is the hashed version of the code verifier. So we take the hashed base 64 URL encoded with no padding, that's important, value of the code verifier. These are the things that they'll be dynamic, but the authority system will trust that these values are ones that are coming from you and that they are ones that it can rely on to authenticate your access to their information. And then finally, there's something called the challenge method. And this is essentially how the hash was made, essentially. It's basically saying, here's the code verifier. This is the random string that the app created. And then we're going to hash the thing to make a code challenge. And by the way, it's hashed with this method. And so the challenge method will let you know the method of the hash that's used. So back to our great diagram that we have of our client application and our authority system. So PagerDuty in our case. That client application will first generate and then save in the session. It'll save the code verifier. And then also creates the code challenge that it's going to pass over. It's saving the code verifier because it's going to need it during that interchange when it starts making requests to PagerDuty, and PagerDuty says, really, are you sure you say you are who you say you are who you say you are? And then they're like, oh yeah, here, I'll even prove it. Here's the code verifier type thing. So we'll watch. So this is what happens. We make the request, send the client ID, send the code challenge. We said the code challenge method, basically saying, here's the challenge. It's this hash version of the verifier. And then also, here's the hash we're using. And then here's the redirect URL, the address that you need to send everything back to. By the way, when I registered, that I gave you that address. So it's a second check that PagerDuty is checking. It's checking the client ID, which it knows, and it's checking the redirect URL. The user sees the same window. For the user, this is the same process that they would see in a client side or a client secret OAuth. They see that same allow or deny window. They hit allow, and then the application passes the auth code back, same as the client secret method. And then that last request for the access token, the client application will say, okay, here's the auth code, here's the client ID, and oh, by the way, here's that code verifier, right? Here's that thing that I generated at the very beginning and hashed for you. You've unhashed it. I know you did because I gave you the method that we use to hash it. And then, by the way, you can compare it. You can validate the code verifier and the code challenge. And so it does that. It validates that. It validates the code that was sent over. And then finally, we get the access token. And so what this looks like, what I'll do is I'll show a slide of the code a little bit, just a little bit of the challenge generation, and then I'll actually pop into the actual code. And so here, what we have is a dry throat at the end of the day. But we also have this authentication function, or auth function. And in this auth function here, we have our code verifier that's calling a function to get our 128-bit or byte string. This is the random value. Excuse me. And then we're going to save it. We're going to save it to session storage as our code verifier. We're then going to create a challenge buffer, which is used to generate the challenge from the code verifier. And then we're actually going to encode that challenge. And then we're going to assemble all of that information into our auth URL. And so that auth URL is actually what kicks off the OAuth process, right? So we have this URL. If you can see down there in the auth URL, it says it's pointing right at app.pagerduty.com, which is our authority system. We're going to send a request to our authority system to say, hey, here's all this information. Let's start off an OAuth flow. And then in this case, we have all of that, and we're taking that auth URL and we're sticking it into a button that we're going to have. That's our authorization button. So now we're going to jump out of this and actually look at some code. So what I'm going to do here I have my code on the left. And Flora, is the resolution okay? Good, okay, cool. So we have the code on the left here. And what I'm going to do is I'm going to actually show our client application, our little sample we have going on here. So on the right-hand side here, I have this application. It does not live inside of PagerDuty. It's actually a GitHub Pages application. It's sitting on PagerDuty samples.github.io. So it's totally sitting outside of PagerDuty, but it wants to be able to get access to a PagerDuty account to get some information to manage some users. It's a bulk user manager because it makes it so you can manage your users in a little bit better way that customers need, or that someone might need. So what I have here is I have my button. Here we have that auth function that we talked a little bit about before in the slides. And I can show you briefly, if we want to go up to our Gen 128X function, this here, again, it's just creating this 128 byte string that we need. Right, actually, I guess that's technically not a string yet. We get our bytes, then we put our bytes into an array, and then we take these values, and then we get to hash it, and that's a lot of fun using the window.crypto library, and then we do a base 64 Unicode as we pass it back. All this stuff is, we're grateful that we have people that are smart, right? That are smarter than, I mean, I know some of you are pretty smart, but this stuff is the kind of stuff I don't think about a lot, but it's nice to have functions that are already built, libraries that are already built that we can use. And so by doing all of this, we get our base 64 Unicode and it generates that for us. We even mention in the sample, this isn't even ours. This is code that was generated by somebody named Mad Murphy at Mozilla, because they had a great way of doing this. And so I have here, all of this here generates my URL for authorizing with PagerDuty. And so this right here is that button that it's populating, the href. And so I'll click on this one here. It pops out of my GitHub Pages application and lands me inside of PagerDuty. This is a little bit smaller, probably can't see it as well, but it's the domain says app.pagerduty.com. Here, I have multiple instances of PagerDuty, so it allows me to select which one. I'm going to say, I'm going to be Scott McDemo, because that's the one I want. And here is authorizing the name of the application. And this application, the name was generated or created when the client application developer actually registered their app. And they said, hey, I'm going to register this app. It's going to be PagerDuty Bulk Use Manager Tool. And it's gonna have this client ID. And the client ID is a client ID I have sitting here. It's actually right here in the URL. I have the client ID sitting right up here in the URL. And this was generated when I registered the application when I was building it. It's gonna have access to this account, and on my behalf, it's gonna read or modify all of my PagerDuty data because I told it could. And that's the scope that I was allowing it to do. I could say authorize, and by authorizing it, it comes back here, and then now my information is coming in from my PagerDuty account. I can come over here and see all my other users. And you see down here at the bottom, I have 197 users because they're all really, really important stuff like Terraform Test 65, really important users. So with that, there's a spot that happens right back here, and I'll actually disconnect, and this is, oh, good. Didn't show the bug. All right, so right here, I'm gonna go back to that process one more time, and right here, right when I hit authorize, it's gonna come back in and make a redirect back to my application because we told it to, right? In this browser, in this URL, we're telling it to redirect back to our PagerDuty samples.github.io PagerDuty Bulk User Manager samples. When it comes back to this page, our JavaScript code is waiting for it, and it's looking for a code, right? So it's looking for some kind of code in the URL params. And so we have that code sitting here. When it gets the code, it's going to say, all right, now I'm going to request a token. It requests a token, it makes a post, it gets that token from this code here. And I want to It's actually a little bit easier to see it on this slide. So that token request, that request here is made by taking that code that we got passed in, taking the redirect URL, taking the client ID, clicking code verifier, which we saved into our session storage, and passing that back to PagerDuty. And that gets us our access token and why we were able to see our application or see our user information there. So a couple thoughts to think about the layers of security, because when I first learned about this, there were a few keys that I was just like, it took me a minute to wrap my head around. And so I was really grateful for people to explain this to me. But the first thing is that you have layers of security. That first layer of security is the fact that we have a redirect URL that must be registered. So it's that redirect, where to send the token, it's saved inside of the authority system. It's saved inside of PagerDuty. So PagerDuty knows, okay, I know that I'm going to send all requests back to this spot. So if you ask me to save it somewhere else, you're not the application you say you are. And so that prevents application mocking. Then we have our code exchange for token. That whole bit where we're making the code verifier and the code challenge, those things are preventing the fact that we're going to have some sort of application in the middle that's trying to hijack what we're trying to do, trying to hijack those requests that are happening back and forth between our trusted client and the authority system. So making those challenges and passing them back and forth, hashing them, is all making it so that we can prevent that app in the middle sort of attack. And then finally, when you take these two layers right there, when you take the fact that we're going to be, we take the registered redirect and we take those code challenges and code verifiers and we put them together, it allows them to know it's just an added layer of security, making triple sure that this application is who it says it is. And it gives the authority system assurance to know that any kind of requests happening through this are requests being made by the client application that it thinks it is. So it knows that my bulk user manager is the application and it only has access to get to the users, or it is only going to talk to users. So those are the benefits or the layers of security that PKCE provides. You can find the sample code that I was going through today on GitHub in the PagerDuty samples repository. And please feel free, to use that sample code. You can get a developer account on PagerDuty if you don't have one, and they're free and they don't expire. You go to developer.pagerduty.com if you want to play with the code and see how that works. And then finally, let's see, Okta. Yeah, Okta has a really good application or really good article on proof key and implementing that. And so that's an article I recommend as well. So I'm Scott McAllister. I'm a developer advocate at PagerDuty. PagerDuty is an incident management platform that allows you to be notified of work when it needs to happen right now. If there's something that needs to be acted upon in the moment, PagerDuty is the application you would use, or the platform you would use. Yeah, so thanks.
Thanks, Scott.